A few decades ago, it genuinely looked like the future of water travel had already shown up. Hydrofoil ships were tearing across rivers and seas at 120 kilometers per hour. They lifted their hulls clean out of the water, sliced through drag like it wasn't even there, and got passengers where they were going several times faster than any ordinary boat. On paper, it looked like the answer. Reality disagreed. Today, almost all of these strange, gorgeous machines have vanished from the world's waterways. Whole countries quietly walked away from them. And here's the part you probably won't guess. The real reason they died has almost nothing to do with speed, or fiddly engineering, or people not wanting them. The truth is stranger than that. In this video, we'll dig into why this technology started losing to plain old, ordinary ships, and how the very speed that was supposed to be its superpower became the thing that killed it. Rewind to 1957. A Soviet engineer named Rostislav Alexiev walks into his lab with an idea that sounds like science fiction, and then he builds it. The world's first mass-produced passenger hydrofoil. And he names it Raketa, which means rocket. And it really did act like one. As it sped up, the whole ship rose onto these thin steel legs. Its belly lifted right off the river, and it flew. The very first run from the city of Gorky down to Kazan took just 7 hours. To put that in perspective, a regular riverboat needed more than a full day for the same distance. A train took 13 hours. So picture the scene. Word gets out. And suddenly, there are these huge lines of people at every pier, all desperate for a ticket on the future. Engineers were riding pure momentum. New models kept rolling out. The Meteor, the Cometa, the Voskhod. Every one built from lightweight aviation-grade aluminum and driven by these monstrous diesel engines. The biggest hydrofoil weighed around 50 tons. Sit with that for a second. That's roughly 35 cars stacked together, and it could still haul itself out of the water and carry up to 120 passengers at 65 kilometers per hour down the Volga and other Soviet rivers. And then came the giant, the Burevestnik. This monster ran on aircraft gas turbine engines and screamed across the water at 100 kilometers per hour. These flying ships started ferrying people across the Volga, the Yenisei, the whole country. Then the world came knocking. Britain, Italy, Germany, Greece, Vietnam, all of them lining up to buy the technology. People were obsessed. You could arrive in 1 hour instead of 1 whole day. But to pull this off, engineers had to break rules shipbuilders had followed for thousands of years. Here's the thing. Water is dense. Really dense. When a normal ship pushes through it, the hull is basically wrestling the river the entire way. The propeller shoves the boat forward, but the hull keeps forcing water out to the sides, and the water shoves back. So to go faster, shipbuilders kept doing the obvious thing. Bigger engines, more fuel. Bigger engines, more fuel. And no matter how much diesel they burned, the ship barely gained a thing. The water just wouldn't clear out of the way fast enough. It was acting like a brake. So the Soviet engineers looked at this and had one of those reckless thoughts that ends up changing history. If water is the enemy, why not lift the hull out of it completely? Get the ship off the river entirely. But how do you lift a steel monster that weighs as much as 10 grown elephants? Their answer was clever. They welded strong metal struts to the underside of the ship, and at the bottom of those struts, they bolted wide, flat steel plates that looked a bit like skis. Sitting at the dock, the ship sank down deep like any normal boat. But the moment the captain slammed the throttle forward and it picked up speed, something almost eerie happened. Lift built up and the hull started squeezing itself upward. First, the nose came free, then the middle, then the whole belly. And there it was. A multi-ton metal beast hanging in the air over the river. The secret behind the trick is simple and kind of beautiful. You felt it 1,000 times without noticing. Think about sticking your hand out a car window. Hold your palm flat and the wind just slides over it. But tilt your fingers up a little and suddenly the wind slams your hand toward the roof. That is exactly what these ships were doing. Engineers took those steel plates and gave them a curved shape, like an airplane wing. As the ship sped up, water rushed past this underwater wing. And here's the part that gets me. Water is 800 times denser than the air holding up jumbo jets. So, even a tiny steel wing the size of a dining table could hoist a load as heavy as a big truck straight out of the river. Once the ship crossed 30 kilometers per hour, the lift actually beat the weight of the whole vessel. The water just spat it upward. The hull rose. The contact area shrank to almost nothing. The braking drag was gone. And the ship flew. It felt like a clean win. The ships were flying, passengers were thrilled, countries were placing orders. Engineers were already sketching superships that would outrun cars on the highway. But what none of them knew yet was that water itself was about to turn into a weapon. A weapon nasty enough to chew solid steel into Swiss cheese in a matter of months. So what was this invisible thing tearing apart their secret test ships? In the 1960s, designers tried pushing new models to 150 kilometers per hour, faster than a car on a country road. They built bigger, more experimental hulls. Then the tests began. And they went sideways fast. At top speed, the ship started shaking. Not a little tremble, violent, teeth-rattling shaking. Bad enough that metal fittings inside the cabins snapped. Bolts popped out of the walls. People couldn't stay on their feet. Captains had to race back to port in a panic. And when engineers hauled the vessels out and looked at the wings, they were horrified. Solid steel, 2 fingers thick, covered in thousands of tiny pits. The plates looked like they'd been dunked in acid or beaten with an iron bar. After just a few months of use, holes were punching clean through the metal. The wings were falling apart. And once they lost their shape, they couldn't hold the ship up. Scientists were stumped. How was plain fresh water ripping apart hardened steel? At first, everyone assumed the wings sliced smoothly through the water. But once a ship passed 80 kilometers per hour, the usual rules of how fluids behave went out the window. The culprit wasn't air. It wasn't rust. It was the water, doing something that sounds impossible. Here's what was going on. When that steel wing knifed through the water at extreme speed, the flow raced over the curved top surface so fast that the pressure up there dropped to a critically low level. You can't see that pressure drop, but it was pulling off a trick you'd never expect. It was making the water boil. Not with heat, with low pressure. We think of boiling as something that only happens with a kettle on a hot stove, but physics has a second door. Drop the pressure around water far enough and it boils too. And that's exactly what was happening on top of that wing. The water there was churning into vapor while staying as cold as the river. A ghostly kind of boil. This nightmare has a name: cavitation. That low-pressure zone was spawning millions of microscopic bubbles a second, each one full of cold vapor and vacuum. The flow tore them off the top of the wing and flung them toward the back edge. And that's where the horror started, because at the back edge, the pressure suddenly shot back up. Those vapor bubbles couldn't survive it, so they collapsed. They imploded. Instantly. Violently. Each collapse was a tiny explosion, vapor snapping back into liquid in microseconds. And those implosions fired off pinpoint shockwaves of unbelievable force. Every strike hit like the weight of a loaded dump truck focused onto the tip of a sewing needle. Millions of these microscopic hammers pounded the same spots on the wing every single second. They literally knocked atoms of steel off the surface until the metal crumbled and gave way. And it got worse. All that foam of collapsing bubbles broke up the smooth flow of water around the wing. The wing couldn't grip the water anymore. Lift instantly dropped to zero. The ship lost its footing and slammed down hard into the river, overloading its engines. Nature had built a wall. A hard speed limit that engineers spent decades trying to punch through and never could. Meanwhile, up on deck, passengers had troubles of their own. As long as the ships stayed on calm, mirror-flat rivers, everything felt magical. But the moment operators tried them out on the open sea, the dream fell apart. Even a light breeze had the ships bucking and slamming like an angry bull. Seasickness became normal. Trips turned miserable. And rivers had their own hazards. Logs, whole tree trunks lost by timber transports floating just under the surface. A log as thick as a telephone pole, nearly invisible in the water. And a captain flying along at speed couldn't spot it until it was too late. A collision at that velocity and the ship stopped dead. That sudden stop threw brutal G-forces through the cabin, endangering everyone aboard. That risk alone was enough to spook the safety inspectors. People got scared to buy tickets. Inspectors kept grounding the fleets over bad weather. Ships sat at the docks for weeks, bleeding money. Here's the deeper problem. These ships lived in a ridiculously fragile balance. A regular boat sits deep in the water, its deck rising up like a 3-story building. Waves can rock it, but it isn't going anywhere. A hydrofoil, though, flies just above the water, with only 1 to 2 meters between its belly and the surface. About the height of a grown man. So picture it. A multi-ton flying beast the size of a city bus, skimming through the air at almost no height, completely at the mercy of the road below. And that road never stops moving. The air forgives airplane pilots because the sky is huge and empty. The water under these ships kept shifting, rising, dropping. Any change in the road, any halfway serious wave, any object in the path shattered the flight in an instant. Captains had to yank the controls and nudge the engines within a fraction of a second just to stay level. Scientists pinned down 2 main causes of the crashes. First, how water behaves at high speed. Around 100 kilometers per hour, water doesn't have time to get out of the way. It starts behaving like a solid. If the ship rammed a floating log, or even a big fish the weight of a sack of potatoes, it was catastrophic. The impact was like driving straight into a brick wall. The aluminum hull crumpled. Wings tore off. Second, loss of lift on big waves. When the ship crossed waves taller than a person, the wing would sometimes punch clear out of the water and hit air. And air, remember, is 800 times thinner than water. It can't hold a ship up. Lift collapsed instantly. The ship dropped like a stone onto the surface. They call this slamming. A flat belly flop with the force of a car falling from a 2nd-story window onto asphalt. The bottom would cave in. Cracks would spread through the support beams. Water would pour in. Ships were coming apart fast. And still, through all of it, the engineers kept fighting. They were sure the problem could be cracked. But then something bigger showed up and finished the job. In 1973, the global oil crisis hit. Fuel prices quadrupled, and suddenly the cost of running these flying boats turned into a horror story. These beasts drank fuel like there was no tomorrow. A normal riverboat cruised slowly and sipped almost no diesel, but a hydrofoil hovered above the water on jet-grade engines. In 1 hour of flight, one of these ships burned as much fuel as the average car goes through in a full year of driving. When oil was cheap, nobody cared. Once the crisis hit, ticket prices went through the roof.
Passengers just walked away and climbed onto buses that cost a fraction of the price. Owners started hemorrhaging money, routes shut down, crews were let go, and these gorgeous flying machines got dragged off to rusty back harbors or cut up for scrap. Executives scrambled to save their businesses. In shipping, there's one iron rule. If you want to move cargo cheaply, you build gigantic ships. A barge the size of 2 football fields, 5 stories tall, packed with thousands of tons of coal. And here's the lovely part. A ship that huge barely burns any more fuel per trip than a small one, so the cost of moving each box drops to pennies. The hydrofoil companies wanted the same magic. They wanted enormous cargo hydrofoils, thousands of tons of goods flying across oceans in a couple of days. Engineers started drawing up plans, and they smacked straight into a wall. Because scaling hydrofoils up simply doesn't work. Building a big cargo hydrofoil was physically impossible. Every attempt fell apart. The reason is a brutal bit of geometry called the square-cube law. Say you take a standard hydrofoil and just double every dimension. Length, width, height. Sounds harmless. But the math is savage. The surface area, wings included, only quadruples. It grows by a factor of 4. The volume, and so the mass, cubes. It grows by a factor of 8. So the ship instantly balloons to the weight of a whole freight train. Meanwhile, the steel wings underneath are now far too small to lift it. There isn't enough lift. To hoist a beast that heavy, you'd need wings so absurdly huge they'd stick out farther than the ship itself, making it impossible to dock or maneuver near shore. You'd need a dozen thirsty turbines just to get it moving. The whole idea turned ridiculous, which is why the flying fleet stayed locked in as passenger transport only. Heavy cargo was off the table, physically and financially. So the flying fleet was cornered. Couldn't carry cargo, couldn't afford to carry people. Was it really all about hungry engines? And how did this supposedly dead technology claw its way back in the 21st century in a form nobody saw coming? By the end of the 20th century, people had basically stopped using hydrofoils, and the killer was something as dull as asphalt. Governments paved thousands of kilometers of roads and bridges. Families bought cars. Buses ran between cities on the hour. Railroads rolled out fast trains. Airlines made flying cheap. Water travel just lost its point. Why buy a hydrofoil ticket that cost as much as a winter coat when a bus could take you there for a fraction of the price? Passengers voted with their wallets. River terminals emptied out. Captains took the last ships to dead-end harbors. And the aluminium machines sat there for years, choked with weeds under the rain, until workers finally cut them up for scrap. The high-speed era on the rivers was over. Humanity had bet on wheels. You'll find plenty of conspiracy theories online saying the fleet was suppressed by oil companies, or that modern engineers just got dumber than their grandfathers. None of it holds up. There was no secret conspiracy. The global economy simply picked safety and low cost over raw speed on the water. The people running the numbers worked out one plain fact. The biggest profits come from massive, slow cargo ships. Vessels the size of 3 football fields, crawling across the ocean at walking pace, carrying millions of boxes of phones, clothes, and food around the world in a single trip. Moving people fast over water is risky and unprofitable. For quick human travel, the land gave us trains.
and the sky gave us planes. Water went back to what it always did best. Cheap bulk cargo in reliable holds. But the dream of flying over water didn't die. In the 21st century, the technology roared back at a completely different scale. Engineers gave up on giant passenger ships as heavy as elephant herds. Instead, they shrank the whole idea down to the size of one human. They used carbon fiber, lighter than an empty plastic bottle, but strong as a steel rail. They swapped heavy diesels for compact electric motors and small lithium batteries, the kind in your phone. Supercomputers help them design a wing shape that no longer suffers from cavitation. Today, those tiny underwater wings are turning up everywhere. On surfboards called electrofoils, you stand on the board, press a trigger on a handheld remote, and you glide silently above the waves. Small pleasure yachts are getting the same treatment. These boats aren't trying to fix global shipping anymore. They found their real home in sport, in play, in freedom. Humanity didn't throw this invention away. It just found the right size and the right job for it. What do you make of this comeback? Drop a comment below, hit like, and share it with someone who loves stories like this one. More coming soon.